Let us consider this problem. Here a client has an estate agent to sell his 3 properties with some conditions. The conditions are: for the first sale, that is property A, the agent will receive 5% commission if he succeeds. If not, he will not be allowed to sell other 2 properties. The details and probability to sell a property is given in a table. Here expected monetary value is the payoff for the decision. Higher the EMV, the best strategy it is. To solve the decision tree, we use 2 symbols. The square is used to take decision. It is called as decision fork, and circle is used for probability of success. It is called as event fork. Now the agent takes a decision to sell property A. The price of this property is 12,000 rupees, and selling cost is 200 rupees. The probability of success is 0.7. Now there will be 2 events. What happens if he sells the property, and, if not? The probability that he can't able to sell is 0.3 and 0.7 to get success. If he sells the property, he will get a profit of 200 rupees. This 200 rupees is achieved by the calculation given, based on 5% commission and selling cost. Now the agent has 3 possibilities. He can choose property B, or property C, or he can stop selling and go. If he chooses to sell property B, he has 2 possibilities. He can't able to sell the property, which has the probability 0.4, and for remaining probability he may sell the property. So, the profit he gets if he sells the property is 1025 rupees. The calculation is shown, with 5% commission and selling cost. If he chooses to sell property C, he has 50% chance to achieve the goal. If he succeeds, he will get a profit of 50 rupees. The calculation is shown, with 5% commission and selling cost. Let us go for the third decision. Here the agent, after selling property B, he has 2 choices. One to stop selling, and other is to sell property C. If he sells property C, he has 50% chance. If he succeeds, he will get a profit of 50 rupees. The calculation is shown. Let us move to decision 4. Here the agent has 2 choices. One is to stop selling, and the other is to sell property B. If he takes decision to sell property B, to succeed, he has 60% chance. So the profit achieved when he succeeds is 1025 rupees. The calculation is shown. Now, we have completed all the possible alternatives. Next step is to choose the right decision through expected monetary value. To calculate the EMV, we have to do the calculation from last to the first. Here the last events are D and E. The EMV is calculated by applying the probability of success. So for event D, the EMV is profit 2050 into 0.5, which is equal to 1025. For event E, it is profit 1025 into 0.6, which is equal to 615. The next is the decision box 3 and decision box 4. These decision box value will be the maximum value of EMV based on its event. For decision box 3, the maximum event is only 1D, that is 1025. For decision box 4, maximum event is event E, that is 615. Let's go for the next event. Event B has a probability of 0.6. It should be multiplied with its profit and decision box value. So, event B is 0.6 into 1025 plus 1025, which is equal to 1230. Similarly, event C is 0.5 into 2050 plus 615, which is equal to 1332.5. Now we will consider decision box 2. Here we have to choose the maximum EMV for event B and event C. So the maximum is 1332.5. Last event A will be 0.7 into 200 plus 1332.5, which is equal to 1072.5. Now the best decision is how we choose the decision box. That is shown. This completes the problem. Note, here the object is to get profit, so the chosen EMV is maximum value. If the objective is to reduce the cost, then the EMV value to be chosen is minimum value. Hope you understand the previous problem. Let us consider another problem based on cost. Let me read the problem. Mr. Sinha has to decide whether or not to drill a well on his farm. In his village, only 40% of the wells drilled were successful, at 200 feet of depth. Some of the farmers who did not get water at 200 feet, drilled further up to 250 feet, but only 60% struck water at 250 feet. Cost of drillings is Rs 50 per feet. Mr. Sinha estimated that he would pay Rs 18,000 during a 5-year period, in the present value terms, if he continues to buy water from the neighbor, rather than go for the well which would have life of 5 years. Mr. Sinha has 3 decisions to make. Should he drill up to 200 feet? If no water is found at 200 feet, should he drill up to 250 feet? Should he continue to buy water from his neighbor? Draw up an appropriate decision tree and determine its optimal decision. As we discussed earlier, we have square box for decision and circle for event probability. Here the objective of the problem is to reduce the cost. No, the farmer has to take decision, either to buy from neighbor, which costs Rs 18,000, or to drill for 200 feet, which costs Rs 10,000. The calculation is given. If he drills for 200 feet, there may be 2 possibilities. He may get water, which has 0.4 probability, or he may not. If he have not got water, he can take a decision. He may stop drilling and can buy from neighbor. Or he may drill for another 50 feet. This costs additional 2,500 rupees. If he drill for 50 feet, he have 2 chances. One, he gets water, which has a probability of 0.4, and other is no water, which makes him to buy from neighbor. Thus it completes our decision alternatives. Next step is to choose the right decision through expected monetary value. To calculate the EMV, we have to do the calculation from last to the first. Here the last events is B. The EMV is calculated by applying the probability of success. At B, the EMV will be 0.6 into 18,000, which is equal to 10,800. Next is decision box 2. Here the decision to be taken is based on lowest EMV, because our objective is to reduce the cost. The cost to buy from neighbor is 18,000. The total cost if we drill for 50 feet is 10,800 plus 2,500, which is equal to 13,300. The minimum of these is 13,300. So we take a decision to drill 50 feet. Next is Event A. The EMV for Event A is 0.6 into 13,300, which is equal to 7,980. Last is Decision Box 1, it should be minimum from drill or buying from neighbor. The cost buying from neighbor is 18,000, and if we drill the cost is 17,980. So the best decision is to drill for 200 feet. The overall decision taken is shown. So the farmer can try to drill, even if he didn't succeed he will gain 20 rupees rather than buying from neighbor.